Welcome back. Apparently you really like to learn from me. Or I just really confused you in class today, which is a good distinct possibility. Actually not. This is a relatively simple unit. This is Algebra 2 Common Core, Unit 1, Day 2. Now, if New York State decides to wise up, this might be just Algebra 2 Trig, Unit 1, Day 2. It doesn't matter. Unit 1 for whether or not you're doing the Algebra 2 Common Core and the Algebra 2 Trig. They're pretty much similar. Not much is going to change. Most of this stuff is just review anyway from what you did in algebra. But we got to bring those cobwebs out. We got to get your brain functioning again. Again, hit that subscribe button. It should be down there somewhere, way over there, somewhere on the bottom. Maybe it's over that way. I don't know. Hit the subscribe button. Could use some more subscribers only because kind of makes me feel good. Makes me feel like I'm loved. Actually, what it does is allows me to get some other stuff. If you would like, and I didn't say this the last time at the beginning, but all of my video notes can be found in a very organized way at mrkrausmath.com. Just click on classes and you can choose class 2, 3, or 4. It doesn't matter. And then there it will say Unit 1, Day 2, Day 3. It'll have the homework assignment. It'll have copies of all my notes that I have here. It will have copies of all my homework assignments that I'm giving out, as well as links to my videos. And so that way you don't have to find me randomly on YouTube. You can just strictly go through my notes. Or you can subscribe, and every time I create a new video and post it, you will get a copy of it in your inbox, just like a little present. Okay, whatever. Let's get to today's stuff. A little review from yesterday, a little bit review from algebra. Shouldn't be taking me too long. Hopefully, see, sometimes this thing doesn't wake up. And again, I'm using Windows 10, so last time it worked out pretty good. We'll see how it's going to go now. Okay, if you remember from yesterday or day 1, remember the domain is the input values, or the x values. They are the independent variables. Independent. If I misspell something, don't tell me about it. I don't know. So it's like the ball going in, the ball goes in, and it pops out with the range. The range are the output values, or the y values, otherwise also known in the math world as the dependent variable. It depends on what ball you put in. Depends on what you get out. Okay, so over here we're going to list out the domain and range. Remember, you only list them once. Even if they're used more than once, we only list them once. And this list should look familiar. I think we had this list yesterday. If I do these in order, I think I go 120 is the lowest. Now notice 120 is used twice, so based on what we talked about yesterday, we're probably going to say that's not a function because we're repeating x values. I hope you say that. 120... 130, let's see, I used 120, use 130, 240's next, 240, and then 260, and then 295, 260, sorry, and 295. Let's see if there's any repeating y values. I don't think so, so we should have 6 values in this one. The range values would be lowest to highest, 882, I'm going to cheat, I'm going to look at my notes, 929, 930, 977, 988, and last but not least 991, and a little curly bracket at the end. Not a function because of the repeating 120s. Not a function. All right, so that fails because we have repeating x values. This one, very clearly you should be able to tell me this is also not a function because it does not pass, or it fails the VLT, the vertical line test. But we can still list out the domain. It's still a relation. It's still a set of points. It's just not a function. So the relation, the domain would be 1, input 1 values, input 2, input 3, and 4. It doesn't always have to go in order like that. And the y values are also 1, 2, 3, 4, and 5. Okay. continuous functions. They have uninterrupted domains. That means it's continuous along a certain value. So if I had to graph this line, it has a y-intercept of 1. There's a slope of 1, up 1, over 1. It's just a line with a slope of 1. And if I plotted it, it would look something like this. It is continuous from the left side to the right side. Very difficult to draw lines. So there's the function. Notice, remember this, we had function notation f of x. That's read f of x. Don't sound stupid. Say f parenthesis x or whatever some people weird says. So the domain for this one is all reals. You learn that in algebra as well. All reals. Another way we can write that is negative infinity is less than x is less than infinity. Remember, this is domain. Again, if I don't tell you and I don't label it domain and range, you're forcing the teacher to guess, and math teachers don't guess. They just guess you got it wrong is what they guess. And you guess they're crazy, but we are. So it goes forever and ever to the right. It goes forever and ever to the left. So domain is all reals. The range, it goes forever and ever up, and it goes forever and ever down. So the range is also all reals. You can write all reals. Or you can write negative infinity is less than x is less than positive infinity. Okay, let's move on. You will also learn this, and believe it or not, this is also review. You learn to do domain and range using two different ways. You learn to use it using inequalities, which is the way I just showed it to you. Or you learned interval notation. So on that last one, I said it was from negative infinity to positive infinity. And I said in inequality notation, that's negative infinity less than x less than positive infinity. If I was using interval notations, for interval notations we use parentheses for not equal to. And we use brackets for equal to. And this was a new topic for you in algebra, but it should not be new now. You can never, ever, ever reach infinity, ever. So if I was to write this in interval notation, I would write parenthesis, negative infinity, comma, positive infinity, parentheses. It says it goes all the way to infinity, but can't equal infinity, because you can always go one more. You never played that stupid game? Infinity. Infinity plus 1. Oh, yeah? Infinity plus 2. Oh, yeah? Infinity plus 3. Infinity plus 4. When you really never, ever can reach infinity. So we're going to practice with this a little bit. We're going to get pretty good at it. So let's just do a little practice down here. Now, this right here says 2 is less than or equal to x is less than infinity. Another way, and probably a more common way you will see this written, is simply x is greater than 2. Now, the reason I wrote it this way is because I want you to see how easy it is to do it in interval notation. Again, this is inequality notation. So here, this is 0. Here's 2. There's negative 2, just to kind of give you a sense of where things are. It has equal to, so I'll put a solid circle here. That's the lowest, and it goes forever and ever to the right. So interval notation would be bracket 2, comma, infinity, and again, we can never equal infinity. This one is saying simply x is greater than 2. Well, it's a very similar graph drawing, 0, negative 2, and 2. But instead of a closed circle, we're going to choose an open circle, arrow going to the right. Now, in order to say that it can't equal 2, we use a parenthesis, 2, comma, infinity, parenthesis. Some of this ringing a bell? Those of you that took Common Core Algebra, this should be old news for you. And all of you should have taken Common Core Algebra. I don't really need this part right here. I could just leave that off if I wanted to. This is just x is less than or equal to 2, which means, again, I go to 2. I only put the negatives in just to kind of get a good sense of what the number line looks like. It's equal to, so it's a closed circle, arrow going to the left. So the lowest number, and whenever we do interval notation, you'll remember that the lowest number goes on the right, comma, highest number. So, and then you have to decide, am I going to use parentheses or brackets? Am I going to use parentheses? That's a bracket, I guess. Or parentheses or brackets. You have to decide how you're going to do that. But lowest goes on the left, highest goes on the right. And it's kind of the same thing. Lowest goes on the left, highest goes on the right here too as well. All right, so I'll come back to this. The lowest number it could be, well, the lowest number we're pointing to is all the way to negative infinity. So that would be negative infinity. I can't equal that, so it's parenthesis. Anytime you write a infinity, negative or positive, it will always be a parenthesis, comma, 2. Now to 2 I can equal, so I'm going to put a bracket on that 2. And again, I really don't need this part here. Oftentimes, almost every single time, you'll never see the infinity on those. So it's just x is less than 2. Again, it's the exact same drawing, except now I have an open circle at 2, arrow going to the left. So instead of equaling 2 here, I put a parenthesis, which shows that it's not equal to. That should be pretty easy. All right, so this one's a crazy one. Let's do this one right here. So this one says we're going from negative 2, negative 1, 0, 1, and 2. So from negative 2, remember, notice it's got a no equal time, so I'm going to use an open circle, to 1. 1's a closed circle. It can be in between those two. Or in interval notation is a little bit different. It can be not equal to 2 and greater than. So it's everything but between 1 and 2, basically, and 2. So you got to be careful with this one. Let's talk about this first piece first. I'm going to do this in blue. I'll do this first piece in blue. So this blue here. All right. So over here in blue, oh, this should be a negative 2. Sorry about that. So it goes from negative 2, that's the small number, to 1, that's the big number. Because I can't equal negative 2, I'll put a parenthesis there. And because it's a solid circle and I have this equal to here on the 1, I got to put a bracket. Now the symbol for or in interval notation is a U, like that. Like a capital U without that little tail there. Just kind of a U like that. It actually stands for the union, putting two things together in one big set. All right, so again, I can't equal 2. That's the small number in this second part over here, right? In this part over here, 2 is the small number. It's pointing to positive infinity. Infinity is the big number, and it can't equal either of them. This one's a little different, a little bit different. So we've got negative 2 here. So here it can equal negative 2 or go all the way down here to negative infinity. I don't need to put on my graph. And it can equal 1. It's a terrible scale. Okay. And it can go that way. That scale's terrible. Sorry about that. It's kind of embarrassing. So it can be less. So let's just talk about this piece right here first. We'll do that piece first. So the smallest it can be is negative infinity. Can't equal it. All the way up to negative 2, and we can equal negative 2. If I talk about this piece, I'll do 2 asterisks. It can equal 1, 1 being the smallest number, and it can go all the way up to positive infinity. It can never equal positive infinity. Whenever the arrows point in 2 different directions, or you have 2 different pieces to the domain, we have to use the U for union. Okay, there we go. So a little practice with that. Now this left, right, up, and down isn't going to play too much into what we do now, but later on when we start doing more complicated functions, thank God I got my microphone turned on, it's going to be a little bit different. So normally our absolute value function, a normal Toolkit absolute value function, starts here at the origin. So where did the origin, or where did this vertex move? It moved a little bit to the left. So we're going to go minus a half to the left. It didn't go up or down. It didn't go right. It went to the left, minus a half. So the domain, remember the domain are the x values. I can use 1 something, I can do 2 something, I can do 3 something. Notice this is going forever and ever and ever in that direction. So it's going forever to positive infinity. It's going to go forever and ever in this direction as well. So the domain is all reals. I can write all reals, or I can do it in 2 different ways. I'm going to do it 2 different ways. Actually, I can do it 3 different ways. All reals. I can write that. I can write negative infinity is less than x is less than positive infinity. Notice I did not put equal to, because you can never equal infinity. Or I can use interval notation, which is usually the fastest. And once you get good at interval notation, you don't really want to go back to anything else. And us math teachers and mathematicians love things that are fast and quick and shortcuts because we're lazy. Now, range is a little bit different. Let me do range in red. Here's the smallest y value, and then it goes forever and ever up, and it goes forever and ever down. But you notice there's no drawing down here. There's nothing down here. So the y values, or the range values, can never be negative. So I can signify this in 2 ways. I can use interval notation. I can say y has to be greater than or equal to 0, just not negative. Or I could say it can equal 0 and go all the way up to positive infinity. It's 2 different ways to write that. All right, let's do this one. So normally our parabola starts here and goes like this, right? We know this is our normal parabola. Well, we moved our vertex to the right and down. So it looks like I went right a half and down, let's just say 2.25 or 2 1/4. Okay. Again, just like the absolute value function, which is the one before this is a parabola or a quadratic. The domain is all reals. It's going to go forever and ever to the left and forever and ever to the right. So I can write all reals. I can say negative infinity is less than x is less than infinity. Or I can use interval notation, negative infinity, comma, positive infinity. All 3 of these are acceptable for domain. And again, you have to label it. If I didn't have the word domain there, I'd have to write it. Here we're going to talk about the range. Now the range, notice, let me try to draw this in yellow here. Notice I'm going to start here and go forever and ever up. And start here and go forever and ever up. But I'm not getting down here below this point. So this point right here is the lowest y value. And we said that was approximately, it was approximately negative 2.25. I probably should have put a negative on there so I didn't confuse you. All right, so my range is not all reals. So I can't write all reals. I would have to write y, remember range is the y values, greater than or equal to negative 2.25. That would be the lowest it goes on the y-axis, the lowest it goes down. Or I could write bracket negative 2.25. Again, I'm estimating that's negative 2.25, comma, all the way up to positive infinity. Again, it can't be equal to positive infinity. All right, the circle. By the way, these 2 are functions. They both pass the vertical line test. I mean, if you were to look at these, they would both pass the vertical line test. No matter what you did or no matter where you went, you could draw any line in there and it passed the vertical line test. So they're both functions. So these are relations that are, in fact, a function. Circles are never a function. Right, fails the vertical line test. So it's not a function, but I still can talk about its domain and range. The center of this circle is at the origin, so I didn't move left, I didn't move right, I didn't move up, and I didn't move down. So I'm not going to talk about those. Those are called vertical and horizontal shifts of our toolkit functions. One of our toolkit functions is, in fact, a circle. We're going to do a lot more of that later this year, but it didn't move, so it has no vertical shift and has no horizontal shift. But we can still talk about the domain. The lowest value here, the lowest x value I have is negative 3, And the highest x value I have is positive 3. And it can equal those, so I would just simply go negative 3, positive 3. Or I could write negative 3 less than or equal to x less than or equal to positive 3. Those are interval and inequality notation. The range, wow, very simply, it goes down 3 and up 3. And that's why it's a circle, because it has the same radius as we go on. Even though it kind of looks like an ellipse, it's really a circle. So the range is the same thing, negative 3 to positive 3, or negative 3 less than or equal to x less than or equal to 3. You must get comfortable with both interval and inequality notation, because I could ask you either on a test, and you have to be able to give me one or the other. All right. This is a cube root function. It's a cube root function. Normally the cube root would go through the origin, because the cube root of x, or cube root of 0, is 0. But it moved to the right 1, so it moved right 1. That doesn't affect the domain. It's going forever and ever to the left, and it's going forever and ever to the right. So that's from negative infinity to positive infinity, or you can write negative infinity less than x or less than positive infinity. And the other thing I can write for this would be all reals, because it could be any real number. Now, the tricky part of this one, and try not to read way too much into all of this, but the tricky part of this one is the range. It looks like, oh, look, it's coming down, it's coming down, it's coming down, but it looks like it might stop at 2. But believe it or not, and remember, we're going forever and ever and ever in that direction. It just keeps going down, even though it's just a teeny tiny bit. It goes forever and ever and ever down. That means it's never going to stop. And the same thing here on the right. It kind of looks like it's getting really close to 2, but it's not. But it is really, in fact, going to go and continue to go up. So for the range, it's once again, or in this case, it's all reals. So negative infinity less than y is less than positive infinity. Or we can do interval notation, which is my favorite because it's the quickest and the easiest to read, quite frankly. All right, let's move on. Piecewise functions. Piecewise function. This idea of a piecewise function means you got a little bit of a piece here, and a little piece here, and a little piece here, and a little piece here. It's not one continuous smooth curve. It's like you got to pick your pencil up and go someplace else and draw another piece, and then pick your pencil up and go someplace else and draw another piece. They're called piecewise functions. It's like lots of functions written as one, and it's going to get a little weird, a little complicated, but it's not bad. It's not bad. I'm not going to talk about shifts of these functions at all, so I probably should have left this out, but I really want you to get thinking about why these are in here. Again, these are for vertical and horizontal shifts. We're going to shift it up, shift it down, shift it right, shift it left. Vertical going up and down, horizontal going left and right. I know I spelled it wrong. I didn't even come close to spelling this right, but whatever, you'll get used to it. Now, domain and range is really weird on these. Okay, so you got to be very careful. The range on this one is going to be very weird. The domain's not so bad. The domain. So, can it be 2? Yep, there's a point with 2. Can it be or negative 2? Can it be negative 1.5? Yeah, right there. Can it be negative 1.2? Yeah, right there. Can it be negative 1.1? Yeah, right there. Can it be negative 1? Oh, wait, we're up here. Yeah, it can be negative 1. Can it be negative a half? Yep, right there. Can it be negative 0.2? Yeah. Can it be negative 0.1? Yep, right there. Can it be 0? Oh, yeah, 0, but 0's up here. So as you go from left to right, as I go from left to right, here, all these points count, but as soon as I get to negative 1, I pop up here, and as soon as I get to 0, I pop up here, and I pop up here. Can it equal 2? Well, no. Notice this is an open circle at 2, right? So it can't equal 2. So there is no 2 something on this graph. So the domain is, yes, it can equal negative 2, comma, all the way up to positive 2, but can't equal positive 2. And this parenthesis says you can get real close. 1.9999999999999999999999999999999999999999999999999999999999999999999999999999999 keep going, but can't equal 2. If I wrote this in inequality notation, I would write negative 2 less than or equal to x less than 2. Remember, we're dealing with the domain of the x values. All right, so the range is a little weird. When x is negative 2, y is negative 2. When x is negative 1.5, y is negative 2. When x is negative 1.1, y is equal to negative 2. When x is negative 1.05, y is negative 2. So one of the values for y is negative 2, right here. Now when x is negative 1, y is negative 1. When x is negative a half, y is negative a half. But you'll notice there's no lines being drawn in between the negative 2 and negative 1. These are discrete. One number, then another number, another number, another number. Not a continuous, it's discrete. One number, then another number. And then sometimes these are called step functions. They kind of look like steps. When x is a half, y is 1. It'll never, do you ever see a y value? Do you ever see any y values or any points over here at a half? No. So whenever you see these kinds of step functions, you're going to have to write these as discrete numbers. The range values are negative 2, or it could be negative 1, or it can be 1, or it can be 2. There's no other y values being used at all. So there's no lines that are being drawn up and down. They're all going horizontal lines going this way. All right, so let's talk about this one. So notice, let's see, it goes forever and ever and ever to the left. Remember, we're talking about domain now. So it goes forever and ever to the left. So the lowest domain value is negative infinity. And then it comes up, comes up, comes up, comes up. So it's negative 1, it's 0, it gets to 1. It can be 1. If it's 1, it's here. What happens if it's 1.1? What happens right here when x is 1.1? Well, then we pop up here. It still can be 1.1. It can be 1.00000000001. Then it's like right here. So this is a solid point here, and this is an open point, and then we go off to the direction this way. So actually the domain is all reals. There's no place that it ever stops, or there isn't a point. There's no place that you can go on here. You can say, hey, the x can't be 5. Well, no, x can be 5. It's just up here somewhere. What happens when x is 1? Well, when x is 1, y is 1. What happens when x is 1.000000000000001? Well, then y is really close to 2. It's down in here somewhere. So it's all reals. Now the range, let's see. The range, can it be 0? Yes. Can it be a half? Yep. Can it be 0.75? Yep. Can it be 1? Yep. Can it be 1.5? Well, I can't be 1.5 in this direction. There's nothing here, but there is the stuff in between here. So basically, what a stupid word. The range is all values that are above the x-axis. Even though it's missing a piece here, it has that piece over here. So the range is y is greater than or equal to 0. Or another way to write that in interval notation is bracket 0, infinity. And when I should have written this in standard notation, negative infinity less than x less than positive infinity. Or I can just write all reals. Okay, let's move on. And finally, again, we're not talking about any shifts. This is just copying things down. So let's take a look at this. The lowest or the smallest y value is over here at negative 1. And the highest x value for domain is positive 3. So and it's got solid points, so it can be equal to. So domain is simply negative 1 all the way up to 3. And I use brackets because they have solid points. Another way to write this would be negative 1 less than or equal to x less than or equal to 3. Range, let me draw a range in a different color. Let me erase this. and we'll do this in, let's say, blue, green. The lowest y value is right here at -1, and the highest y value is +1. It doesn't go above here, and it doesn't go below here. So my range, and they're solid points, so my range is bracket -1, comma 1, bracket, because it can be equal to, or I can write -1 less than or equal to y less than or equal to 1. All right. We are almost done with this lesson. Wow, this is a fast one. All right, so we're going to choose an appropriate window. Sometimes we want you to actually use your brain. Now remember, function notation is more descriptive. Notice we've got this function called h of t, where h stands for the height, which is the y values, or the output values. T represents the time. It's the independent variable. Independent variable. So, and that's, in this case, it's in seconds. You got to be careful. This is in seconds. So I want to know what the approximate domain and range is for the graph. Now I haven't given you any parameters for the problem. I'm just telling you to use your brain. So sometimes you have to decide, okay, let's think about what some possibilities are. So if you've got a new baby bird, that means it's probably in a nest, which is probably in a tree. Now, the tallest trees in the world are redwoods. I'm hoping that there's not too many birds in a redwood. Redwoods probably grow, I have no idea how tall. Let's see if hey, Cortana. See, you gotta love Windows 10. Let's try it here. It's supposed to pop up. How tall is the tallest redwood tree?
Something went wrong. Try again in a little bit.
No, fix it now. How tall is the tallest redwood tree? Here we go. Gotta love Cortana. It's helping us out. Cortana is Windows 10. Sierra redwood trees are the largest trees in the world. Many Sierra redwoods are between 250 and 300 feet. The tallest being about 325. So, I guess if you were dealing with the range and you wanted to really include every tree ever imaginable, like the redwoods, you would say, okay, height is h of t. We'll talk about that actually in a second. Well, actually, let's talk about that now. The range, which are the y values, they're the y values, or they're the function values, in this case, h of t, the height. The lowest a tree could be would be like, that could have a, wait, hold on a second. What is the approximate domain and range? So h of t is the height of the baby bird during its first flying lesson. Well, if you know anything about birds and their first flying lesson, it usually includes them falling out onto the ground. So height of the tree. Now, that means our lowest value can be 0. That would be, if you were talking about a bird on its first flight, probably going to hit the ground sometime because they don't really know how to fly yet. So it will hit the ground at 0. And the tallest it can be ever, if you get to the very tippy top of a tree, is 325 feet. And that would include the tallest tree. That would be like a bald eagle with a bird's nest all the way at the top. Probably not inappropriate. You know, if I was picking a scale for like 90% of the birds, I might pick 30 feet. Because most birds, probably trees that are 30 feet tall, would be the tallest you'd find a bird in. Now the range, or the domain. The domain of a bird flying. Well, let's see. The time in seconds of the flight. Well, a bird's got to start the flight, and as soon as they start the flight, just that teeny tiny little moment of time before they start their flight is time zero. So it can equal time zero. At time zero, it's in the nest. It's at whatever the nest height is. And it goes all the way until it finishes. Well, generally, that part is falling out of the tree. So if it was a 325-foot tree, I'm guessing it's only going to have one flight in its life, because probably not going to survive that. But let's just say it was, and it fell straight down, and anybody that knows anything about physics knows that the acceleration due to gravity is negative 32 point something feet per second squared, which means it's going 32 feet per second squared at 325 feet. The longest it will ever be in the air falling down without wind resistance would be about 10 seconds. So 10 seconds of flight, even if it's at this 325 feet. Now, again, this neglects it actually flapping its wings and maybe going up and then going back down. 10 seconds. Now, 90% of birds on their first flight might be from 0 to 5. But these could be considered appropriate windows. Notice I don't have anything negative. Notice there's nothing negative. Why would I have negative time or negative height? Now, when you're in physics, you'll have negative lengths, but they're called vectors. It's a little bit different. You'll deal with those in physics. They're not really going to be called negative lengths. They are lengths with direction involved with them. And sometimes those are negative and sometimes those are positive. But you can deal with that in physics class. All right, so this problem right here in 9th grade you probably couldn't do. The reason being is there's more than 8 words. And anything more than 8 words is something that we're not going to do. So let's talk, you read through it hopefully by now. We're talking about students that are between the ages of 14 and 15 are limited in what hours they can work. All work must be performed outside of school hours. They may not work for more than 3 hours between Monday and Friday. They may not work for more than 18 hours in a week when school is in session. They may not work more than 8 hours in one day when school is not in session. And if a student works at a job where they're paid a minimum wage of $8.75 an hour, not the $15 an hour these crazy politicians are talking about, what would be the approximate domain and range for the function? W of t, where W is the wages and T are the number of hours. All right, during a school week. So T represents the number of hours. It is the independent variable or the domain. And we said here we're not allowed to work more than 18 hours per week. No matter what, I'm not allowed to work more than 18 hours per week. So my domain could be 0 hours. Maybe some weeks I don't get any hours. Or I can max out at 18 hours a week. So that would be my domain. Did I label my domain and range up here? Yes, I did. Yay. Now my range or my functional values, W of T, are my wages. How much money I'm going to make. Well, the lowest I can make if I work no hours is $0. The highest I can work is 18 times 8.75. I'm not going to bust out the calculator. I think it's $157.50. So the highest amount of money I can make is $157.50. And that would be my range. I can equal that if I max out at 18 hours. And this would be my range. Notice again, there's no negatives. You're not working for negative hours. There's no such thing as negative hours. Never, ever in your life will there be negative hours. Probably never, ever will there be negative hours. But who knows? I hate to say never, ever. I don't think you can go back in time. I think the time is the one thing that will always stay consistently going in that direction and never go in that direction. So not going to have negative time. And you also can't have negative money. So you can't have negative time and you can't have negative money. All right. Mike and Brett, I should have put H. Mike Healy and Brett Healy. Just kidding, boys. Are out practicing for their sectional baseball game. Trust me when I tell you, these two boys are not playing baseball. If the two boys are throwing the ball back and forth, let H of T represent the height of the ball. So H of T is the height. Now, if it didn't tell you what T units were, I think a good thing to ask you, what would be a good unit? Well, clearly minutes aren't a good units for time. Hours clearly are not. Days, can you throw a ball that stays in the air for days? Can you throw in a ball that stays in the air for hours or an hour? Mm-mm. How about minutes? I can't throw a ball that can stay up in the air for a minute. So the units would be seconds. And even seconds, you're not going to have that many. But seconds is probably what you're going to want to use. And I do, in fact, tell you that's the time is in seconds. So the domain is time. It is the independent variable domain. So just before that ball leaves my hand, it's still in my hand, which means it is at time 0. Now, if I really, really, really throw the ball hard, and he's really far away, it might take 2 seconds, 3 seconds in the air, 1001, 1002, 1003. I'm going to guess most people can't throw a ball that stays up in the air more than about 3 seconds, especially if you're practicing with your neighbor. The idea of baseball is to get that ball to the person as quickly as possible, not to keep it floating in the air. So maybe my domain would be something like from 0 to 3. 3 would be an awful long time for a ball to be in the air. Range. Now, range is an interesting one. Now, you got to be careful on range. Think about this. This is the ground right here. And this is the height of the ball, or H of T. Correct? So what is the lowest value that H can be? Can H be on the ground? Well, not if we're playing catch. Normally you want to catch the ball here, or catch the ball here, or maybe catch the ball off to the side a little bit, but you certainly don't want to catch it on the ground. So the lowest value wouldn't be 0, but maybe you catch it down by your knees. What would be an appropriate window for playing catch with somebody? What would be an appropriate window for baseball? I would say if we're playing catch, If I would say we're playing catch, generally the ball is going to go from 5 feet, 4 feet to maybe 20, maybe 30 feet in the air. 30 feet would be a big lobbing ball. But it would never hit the ground. Not if I'm playing catch, not if I'm any good. So it wouldn't hit the ground. So I would say it has to be above the ground, 0. And maybe even 1 would be a better choice. 1 foot above the ground. This is in feet, right? In feet. Or 0 feet. It's certainly not equal to 0. Because if it's equal to 0, we're not playing catch. We're rolling the ball on the ground. And then maybe the highest it could go is about 30 feet. If I'm playing catch with somebody, I'm not throwing it 30 feet. In general, if I was asked for like 95% of the throwing, I'd say, that's about from 5 feet to 20 feet. Maybe 20 feet in the air. Most throwing is here. But if you wanted to look at the entire window, you would have to assume that maybe sometimes you catch the ball near your feet. And maybe you catch the ball, and maybe the ball gets way up in the air. So maybe this includes all the range. But notice again, no negative numbers. Doesn't even include 0 because, again, if we're at 0, we're not playing catch. We didn't catch the ball. It fell on the ground. Which I guess it could happen. I guess if we are playing catch, it could happen. But let's assume that they're good and don't drop the ball. I guess if you put 0 with a bracket there, you could argue the point that it could equal 0. But maybe not. At any rate, okay, there we go. That's it. That's all she wrote. That's the end of domain and range thinking. Okay, hope you had fun. Hit the subscribe button. Hope you learned something. Take it easy, guys. It's been fun, and it's been real, but it's math, so it hasn't been real fun. Bye.